Here's the problem. Find the sum of the first n primes. Alright, let's break this down. First of all, you need to know whether or not a number is prime. We know, probably from memorization, that 2 is prime, 3 is prime, 5 is prime, 7 is prime, and so on. But if you think about it, the definition of a prime number is a number that's divisible only by itself and 1, right? So 2 is the first prime number because it's only divisible by 1 and 2. 3 is the next prime number because it's not divisible by 2. 4 is not prime because it's divisible by 2, which is not 1 or 4. Let's take 11, for example. 11 is divisible by 1 and 11. But is it divisible by any of the numbers between 1 and 11? That would be 2 through 10, right? So if we divide 11 by 2, we get a remainder. Rather, if we mod 11 with 2, we get a remainder of 1. If we mod it with 3, we get a remainder of 2, and so on. So if you don't know how to tell whether or not a number is prime, I'll be showing some code for that in a little bit, but let's move on. Is a number even or odd? Is a number a Fibonacci number? What I'm trying to get at here is this question, find the sum of the first n primes. This could be find the sum of the first n even numbers. Or it could be find the sum of the first n, Fibonacci numbers. Basically, any series of numbers that you want, you can find the sum of the first in that series, the first x numbers, first n numbers in that series. So for this problem, it happens to be find the sum of the first n primes. This doesn't really matter. We just need some way to tell whether or not a number is a member of a series. Okay, so find the sum of the first n primes. Before we can find the sum of the first n primes, right? Like, let's say we had the first n primes, 2, 3, 5, right? A list of numbers, 2, 3, and 5. Well, we need this in order to sum it up, right? We can't sum this list up if we don't have the list. So really, the hidden problem here, besides determining if a number is prime or not, rather than just finding the sum of the first n primes, we need to find the first n primes. We need to find those numbers so that we can sum them up. And so, step 1, we need to find the first n primes. So we need a way to see if a number is prime, and that's a function. Given a number, it returns true if the number is prime, false if it's not. We can start counting up from, let's say, 0, and we'll check each number. We'll say, hey, number, are you prime? And if it's prime, then we'll take it, aka we'll add that number to a list. So we'll start at 0. We'll say, 0, are you prime? No. 1, are you prime? No. 2, are you prime? Yes. Add it to the list. Now your list has 2. 3, are you prime? Yes. Add it to your list. 4, are you prime? No. 5, are you prime? Yes. 6, are you prime? No. 7, are you prime? Yes. So we just keep doing that until the number of numbers in our list is the number of numbers we want. Okay. And after we have our list of numbers that are prime, the number of numbers that we want, we just sum them up. Now, I don't like using atom, so let's look at the console. Here's a little bit of bash. Can't enlarge it. Hopefully you can read this. Oh my gosh. There we go. Here's a little bit of bash. So I'm going to start a number at 1, and while it's less than or equal to 10, I'm going to increment the number, and I want to run my program sum n primes of the number, and then sleep half a second. So let me run that again. The sum of just 1 prime is 2. The sum of the first 2 primes is 5. The sum of the first 3 primes is 10, and so on. So that's pretty cool. Let's see it one more time in action. Yes, this was done with JavaScript, although this code right here, that's bash. Alright, so why don't we take a look at the code that made this little command line program possible right here. That one right there. I could say, node sum n primes. Let's say I want the sum of the first 4 primes. That would be 2 plus 3 plus 5 plus 7, right? So what is that? 17? And it works. Okay, so like I said, let's take a look at the code. Well, I got a bunch of blank screens here, don't I? If we go back to the little presentation I made, the first thing we need to do is find out whether or not a number is prime. So, here we have the code for that. Function is prime. It takes a number called p. The definition of a prime number is a number that's divisible only by 1 or itself. So 2 is the first prime number, and negative numbers are less than 2. So if the number is less than 2, then it's not prime. And if the number is like 5.5, that has a decimal portion, so it's not prime. So we just do this little check here and say, if it's less than 2, we're not an integer, return false. Now, then we just start counting from the first prime 2, all the way up to just before the number we're checking. And for each number, let's say we wanted to see if 7 was prime. Well, we would say, hey, 7 mod 2, is you equal to 0? No, it's equal to 1. So we'd increment I to 3. We'd say 7 mod 3, are you equal to 0? No, it's equal to 1 again. 7 mod 4, are you equal to 0? No, it's equal to 3, and so on. We'd say 7 mod 6, are you equal to 0? No, it's equal to 1. So we never get a number, we never get a modulo equal to 0 or remainder equal to 0, so we never return the false. So for 7, we return true. So isPrime is a function that's used a lot in a lot of courses and classes that teach programming, and here's my implementation. All right, so with given isPrime, we can see if a number is prime or not. And don't believe me? Well, let's test it out. Node and let's see what's in my directory. I've got these files, and I can require them. So I'll say var isPrime equals require isPrime.js, and now I can say isPrime 2. Yes, okay, it is prime. 3, yep. Oh, but what about 10? Is 10 prime? It's even. It shouldn't be prime. It's divisible by 2 and 5. Shouldn't be prime, and it's not prime. So that's pretty cool. You can require your functions. All right, let's move on. We now have a way to see if a number is prime. So we can check this off our list. Now we need to start counting up, taking just the primes. So we need a function first n primes. And that is not it. There it is. So first n primes, we will have an empty list, and we'll have a number that could be prime. It's a candidate for primeness, primality, whatever. We can say, while the number of primes that I have is less than the number of primes that I want, right? You passed in the number of primes that you want. So while the number of primes you have is less than the number of primes you want, call isPrime on candidate incremented. So we'll increment candidate from 0 to 1. That's pre-increment. So it goes 0 to 1, so it's 1. And we say, hey, isPrime is 1 prime. Well, it's going to return false. So we should not add 1 to our list. So we don't push 1, and prime's length stays 0. So we say, hey, 0 less than, let's say we want a sum of, let's say we want the first 3 primes. Well, 0 is less than 3, so we keep going. We increment candidate to 2, we say isPrime 2, yeah, it is. So we push 2, and now the length of our primes array is 1. 1 is less than 3. So we keep going, and we get a list of 2, 3, and 5. So let's see that in action. Well, we can require that as well. We can say var first n primes equals require. So we require this JavaScript thanks to the exports utility. And now I can get the first 3 primes. There we go. So we'll look at that more in detail. I'll try it one more time. Let's see the first. Let's see the first 10 primes. 29. Cool. Looks good to me. So we now have a way to check if a number is prime, and we have a way to check if, or to get the first n primes. So if we want the first 3 primes, we can have it. If we want the first 10 primes, we can have it. Finally, the problem that we want to solve is find the sum of the first n primes. So we've solved this. Find the first n primes. We've taken care of all this. We just need to get the sum. Well, find the first n primes. What does that give us? That gives us an array, right? So what we really need is just a function that finds the sum of an array. And so here is a function, array sum. It takes an array, starts a sum at 0, and we just loop through the array. Array indices start at 0, so we say I equals 0, I is less than array.length, I plus plus, and we increment our sum by the current element in the array, and then we just return the sum. And let's test that out as well. If we open node, I can say require array sum.js. And if I don't say var something equals require, this will just give me back a function. And I can't use it because I haven't given it a name. I haven't stored it in a variable. But I can instantly use it, instantaneously use it. I can say, get me the array sum of I don't know, 1, 2, 3. That should be 6, and it works. And I could also just assign it. I can say var array sum equals, and I can say array sum 1, 2, 3. Okay, let's add in another one, 4. Right, so array sum works. So we have is prime, first n primes, and array sum. Let's put it all together. We require is prime. We require first n primes. We require array sum. And now we can finally answer the question, find the sum of the first n primes. First, we'll just find the first n primes. So we pass in how many primes we want to sum up, and then we get those primes. So var primes equals first n primes, taking the number of primes we want. Then primes will be an array of primes, the ones that we want to sum up. So then we just call our function array sum, and we give it an array, the list of the first n primes. That will come back with the sum of that array, the sum of the first n primes. We store it in sum, and then we just return it. We could have said return array sum primes, but I'm trying to be explicit. And finally, I went out of my way to make this in a cool little command line program. When you pass arguments to a program, in my example here, I say node sum n primes number. So I'm calling the sum n primes program. I'm telling my computer I want to run that file with Node, right? This is a JavaScript file, so I want to interpret it with Node. It's a JavaScript interpreter. That's what Node.js is. But this right here, number, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You can pass arguments to programs, and you can grab them in process.argv. Process.argv is an array of the arguments. Now, the first 2 arguments to the program, I think it's something like one of them is the name of the file itself, and the other one is the directory, I think. We don't want those. We don't want those arguments. We want the arguments that we passed, right? We want what is it? Node, what is it? Sum? Yeah, sum, and we want this 3 right here, this number 3. That's the argument we're passing to the program. So to grab that, you can just slice the arguments starting at 2, because 2 is the 3rd element in the array, and we want to skip the first 2, the program name and the directory. We don't care. So we start with the 3rd argument, which is the element at index 2, right? And that gives us an array. Now, if there are no other arguments, then it would be an empty array with a length of 0. So we say if command line arguments.length, that basically means if it's 0, it's false, right? But if the length is not 0, there must be an argument. So then we just take the first argument, or no, we take the first element, or only element, of our command line arguments, which is the number of primes we want to sum up, right? And we just pass it to sum n primes, and then we console.log it. So with these 3 lines of code right here, you can make command line programs, which is pretty cool. Now let's talk about one more thing before I finish up this video. You may have noticed that this whole file here is a little short, right? This is a little short. Well, that's thanks to require and module.exports. You'll see over here I said module.exports equals function. What this does is it makes it so that elsewhere in other files I can require this file. Now this file is called isprime.js. So if I require isprime.js, then whatever module.exports is, require will return. So require returns this function that I'm highlighting, and I store that function in isprime. I didn't have to name it the same as this over here, but I did. So same thing over here. I have a file called array sum, and I export it, and here I require it. You can think of require as import as the opposite of export. Same thing over here. I have first n primes. Instead of saying module.exports equals function, I defined the function, and later I exported it. It works this way. It also works this way. So anyway, this is exported, this is exported, this is exported, and I import all 3 here, and then I use them here. And if I wanted to, I could even require sum n primes and use that in a Node program as well, just like this. I can start up Node, I can say var sum n primes equals require sum n primes, and now I can say sum n primes, I don't know, 4, and it works. All right, good luck with your studying.